So, good morning everyone. Welcome to today's session on increase your profitability with simulation. My name is Nikhil Fernandez and I'm the simulation consultant at Cadmus. I've been working in this position for almost 2 years now, and I would like to bring about why I'm so passionate about this particular field in our industry. So what's the agenda that we have going on for today? We want to try and help you bring about the engineering or your R&D team to make it more efficient. And once you get it more efficient, you also boost the innovation throughout your entire company process. And once you get more innovative products back to the market, we strengthen our position in terms of facing competition. So who is Cadmus? Cadmus is a reseller for SOLIDWORKS products in the Benelux area. We also have a branch in South Africa, and we are recently a part of the Beckler group as well. So first of all, let's consider the problem and why we should start carrying out tests in the first place. With the test, we try to find an answer to complex design questions such as, what are the forces acting on my parts? Is the piece strong enough to withstand the load? Designers usually get to work with analytical models to answer such questions. A book of strength theory, machine parts, or the table's book of mechanics is therefore often easy to find on the designer's desk. The analytical methods are often only applicable to simple models or very simple geometries. However, in today's world and rapid engineering cycle, we have parts or geometries that are very complex in nature, and our simple analytical methods might not be good enough. And in order to go away from these simple analytical methods, we make use of prototypes. But making use of prototypes can take a lot of time and money as well in this process. So now that we better understand why testing and research are necessary, we take a closer look at the number of challenges that the design department faces while testing a design. For this, we try to imagine a part and go through the different phases of the design process. The part will have to meet a number of requirements. Sometimes they could be like simple things like color, or then we talk about weight and the type of material we're going to use. But usually this also means more complex requirements such as determining a minimum strength or the lifetime of the design. In order to be able to closely investigate such requirements, it is important to properly understand how a component is influenced from the outside. And this means like what are the forces acting on the part, whether it's a static load, that means it does not vary with time, or we have a lot of vibrations happening on the model, that needs to be taken into account. Or we can even consider how a temperature of the surrounding environment can influence the performance of your part. So once we have an idea about the loads on the design, mechanical analysis is often the first thing that is investigated in product development. In the first instance, we think of the strength of the design. Engineers use analytical methods that tell them something about how the design will react to the load. What are the tensions and distortions that will arise, whether or not the piece will be able to withstand the load. Such methods are generally simplified and usually only applicable for small pieces or simple parts. And often only a static examination is done. More complex themes such as fatigue analysis or a component that is subjected to time-varying loads will not be able to take into account correctly in our design process. Therefore, the examination of mechanical components is so complex that there is virtually no analytical method to be able to make a statement about the durability of the product or the design. The only solution is a physical test in order to investigate the behavior of design. a physical test that is usually expensive and time consuming, so one tries to keep this to a minimum amount as possible. Now comes the question is, as we have designed a particular component, we show it to the various or the current design team or the R&D department or the communications team of the company, and we get suggestions like, oh, why don't we go about thinking about making this product lighter or stronger? And if we have it in the simulation phase itself, this is where we can go about optimizing our products to make it the most optimal shape with stronger materials, and we overall make it a lighter component and make our product much more competitive in the market. In the previous slides, we mainly looked at the performance of our design in the interaction with the environment where the product is used on a daily basis. A topic that can also be quite complex is the manufacturing process. The production method is often the know-how that a company can use to make it faster, better, and stronger quality than its competitors. Consider the metal forming process. There are few companies on the market that can produce such products. Not only is the necessary machinery not available for this, it also requires other knowledge within the company to start making these products. This knowledge is probably built up by experience or through years of improvement projects and testing. But do we really understand why this product should take place in this certain way? And simulation can help us figure out if we are doing it in the correct manner or not. A normal design cycle of the R&D department is done through a series design cycle. That is, we have the initial concept phase, then we move into making it a very designed model, a detailed model, and then we go about making prototypes and validating them. And once we finish the prototyping phase and everything is certified, we then move on to production. An alternative approach is a parallel design cycle. This involves attempting to involve test and validation steps earlier in the design cycle. In addition, eventual errors or problems can be identified more quickly. The earlier that this can be done in the design process, the faster a confirmation can be formulated so that the design also meets the customers or the company's expectations. It will therefore increase our confidence and make sure that the developments are moving in the correct direction. The chance of reworking or reshaping the part will therefore be much lower than in the serial design process. We also see that the lead time of a parallel design cycle is shorter than the traditional one. In a conventional design process, tests are often performed at the end of the design cycle. Design flaws that come to light during these tests often result in extra weight, additional costs, and a later startup of series production. That means the manufacturing would be much later. The subsequent placing on the market of a product may have an immediate impact on a company's market share. And we always try to make our company's market share be up. So to reduce the development time, testing should be integrated into the design cycle as early as possible. Based on the results, any changes can therefore be made earlier in the development process. Early changes are usually a lot easier and cheaper to implement, and also ensure that the further design process evolves in the right direction. The quick feedback of testing or concepts early in the design process also ensures greater design freedom and the ability to explore innovative ideas. So when we have later testing in the design cycle, we often lead to very long lead times, which often puts pressure on the competitiveness on the market. Oversizing parts, for example, turned out to be too weak after the initial test, and for which there was not enough time to look for an alternative. Expensive prototypes, which means that they are often avoided or used as little as possible. So we're looking out for a solution that can advance testing in the design cycle. And we have a solution for you, and that is the simulation. This solution fits perfectly into a company's digitization process to start using virtual testing methods. And SOLIDWORKS simulation offers a great solution to virtually test these products while incorporating a lot of complex design environments or conditions. The great thing about SOLIDWORKS simulation is that it's a fully integrated product. That means that you can design your product in the same interface and simulate it in the same environment as well, without having the need to export your files to different softwares. So let's now dive deeper into some of the possibilities that SOLIDWORKS simulation has to offer us. First of all, there is SOLIDWORKS simulation that makes it possible to calculate mechanical and thermal studies, among other things. This package is ideal for reducing cost and helps to reduce prototypes and implementing of physical testing. SOLIDWORKS Plastics often focuses on the injection molding process, or companies that want to produce plastics as quickly as possible so that they have a better understanding of how the manufacturing of their parts are. And finally, there is SOLIDWORKS Flow Simulation, which specializes in the analysis of liquids and gases, heat transfer in a heat exchanger, as you can see in the picture over here, and the effect of the fluid on the surrounding structure. Let's take a look at how these solutions make virtual testing possible. In this slide, we can see how we can simulate the movement of a particular assembly or a component without actually putting it into a prototype test. And based on this, we can calculate our reaction forces acting on these parts, and we can then know for certain whether the stresses in our parts are quite high or not. And by knowing these values, we can then go back into the design phase and change certain aspects of the dimensions of the geometry. Virtual testing is best known for examining the mechanical strength of a design. The part is inserted, loaded by external force, and then calculated to find the internal stresses. The resulting stresses are then compared to the maximum yield strength that a material can withstand, in order to get an indication or not whether the design will be sufficiently strong. If the load is applied cyclically, the part can be then searched for fatigue. The goal here is to make a prediction about the life cycle of this component. It could also be that the component is heavily loaded, that plastic deformation occurs. This can be investigated with the help of virtual test. It also allows us to determine how much plastic deformation can occur in a part and whether it can still withstand the applied load after deformation. For certain companies, thermal examination of their designs is important. Think, for example, the production process where things are melted down. Engines that generate a certain amount of heat, we try to direct through cooling fans. Heat exchangers or radiators are other two examples that generate a lot of heat. And now SOLIDWORKS simulation offers a solution in the form of thermal simulation. Heat conduction, convection, and radiation can be taken into account for our analysis. There's also a possibility to investigate a time-dependent problem like an LED lamp getting heated up after a certain amount of time, or we can do it in a steady-state solution where it is in equilibrium with the surroundings. The resulting temperature distribution can then be used as a basis to analyze the design mechanically. With SOLIDWORKS plastics, the production parameters, the design of the mold, as well as the injection molded pieces can be virtually tested. Questions such as, do I get air traps or air inclusions in the part during the manufacturing process? Or is there enough cooling in the mold for our ejection of the mold? Can be answered. For example, this illustration shows how 4 different injection examples cause a different filling in the die. With this virtual method, it is easy to compare the variants, make a well-founded choice for the optimal solution, and build a good mold based on this. The analysis of liquids and gases moving in and around an object can be investigated with SOLIDWORKS flow simulation. The world of fluid mechanics or flow theory is quite a complex field. In fact, it is true today that only for a simple cases a theoretical solution for the underlying physics model can be found. In most cases, in addition to performing a physical test, a virtual testing is the only method to analyze a design in terms of fluid mechanics. Such simulation gives the information on how the liquid or gas flows through an object. It tells us something about the resulting pressure and the pressure drop and the interaction with the object itself. For example, it can also be investigated how liquids and gases mix together to form a suitable concentrated substance. Like, take example for the pharmaceutical or the mixing industry. Virtual test methods also make it possible to optimize our design. This video illustrates the process of how we are going to use optimization and topology optimization in order to reduce the weight of our part as well as save cost on material components.
The design of most products requires managing conflicting design constraints. Optimizing all these variables can be a challenge, especially early in the design process. Let's look at a familiar product, an off-road bike. It must be lightweight but strong, stiff but forgiving on impact, all while being able to endure the extreme loads and abuse it will see in its lifetime. How can we solve all these challenges? Let's look closer at the rear suspension of our bike and focus on this rocker arm. Designs often begin like this, with a basic functional shape. Finding the ideal geometry to meet performance goals can be automated using a topology study. Traditional simulation fixtures, like these bearing surfaces, are quick and easy to apply. Next, we'll add the force the rear suspension shock applies as the rider hits bumps and jumps. Finally, we add our design goals and constraints. We want the best stiffness to weight ratio while eliminating low-frequency vibration. Now we let SOLIDWORKS calculate the ideal topology. With study results complete, we can quickly see where the geometry can be removed without compromising design performance. We'll use these results to guide the creation of machinable features and finish the rocker design, optimized for weight, stiffness, and this manufacturing process. SOLIDWORKS simulation gives every designer the tools to evaluate how their designs will work in the real world, allowing them to make critical design decisions with confidence. Guide your next design with SOLIDWORKS simulation and quickly achieve your goals.
So now this is a topic that is really dear to my heart, that is sustainability. And now in SOLIDWORKS simulation, we also have something called sustainability, where we can think about, as we design our products, how we can help create a sustainable environment and reduce our ecological footprint. With SOLIDWORKS sustainability, designs can be compared based on 4 major important factors: the carbon dioxide emissions, the total energy the product consumes during its life course, air pollution based on sulfur dioxide emissions, and the emission of phosphate that can have a major impact on the contamination of drinking water. These factors are calculated for the entire life cycle of the product. This takes into account the production of the basic material, the production of the product itself, the transport, energy, and the emissions during the lifetime and possible recycling. This sustainability tool, which is available in SOLIDWORKS Premium, has more than 10,000 users worldwide and is based on the current industrial data. Now the question you guys might be asking is, how accurate is SOLIDWORKS simulation? There have been a lot of validation and verification tests for simple problems where we have shown that SOLIDWORKS simulation is within 1% of the ideal solution. So this was, in a nutshell, the various possibilities where we can use virtual testing to better design our products. By using these technologies early in the design process, we can thus achieve a number of advantages over traditional physical testing. The ability to examine the design in detail first and foremost ensures greater innovation effectiveness. Design becomes more efficient and often more optimized for the application process. Researching different variations become a lot more accessible for the designers, and the confidence to lay down a good design is obtained in such a way. By using virtual tests early in the design process, problems can be identified early. This can save unnecessary cost where, for example, physical prototypes would be necessary to validate a design. This also results in products being brought to the market faster. The well-founded analysis also increased knowledge about the product within the organization, resulting in a better assessment of the risk and the prevention of joint failure of a product. SOLIDWORKS simulation offers a solution to many of the challenges. Due to the good integration with the CAD package, it has also been ensured that the simulation technology has become more accessible to the designer than ever before. A number of solutions that certainly deserve a place in companies that are transforming our industries digitally today. I hope to have given you a nice first impression of what virtual testing could mean for you and how this technology can support the digital transformation of your company. With this, I would like to end my presentation. So thank you so much, guys, for your attention in this session. And if you like this presentation, please do join us on our Facebook page or on our LinkedIn page, where we put together a lot of tips and tricks on how you can use your SOLIDWORKS more effectively in designing and simulating better components. I hope you include simulation in your design process from now on. Thank you so much once again. Bye-bye.